This paper talks about the thermal Hall effect. So actually the Hall effect is just due to the interaction of charged particle with magnetic field, but in this paper, sometimes phonon also display similar phenomena. So let us see what is in this paper. So the title of paper is Discovery of Universal Phonon Thermal Hall Effect in Crystals. (2025) and the team is from Fudan University, Shanghai, China. So they went looking for the thermal Hall effect in a bunch of common non-magnetic materials where one would really not expect to see this kind of phenomenon. So the thermal Hall effect is like when you apply magnetic field and heat current on a crystal, then you can observe a tiny temperature difference perpendicular to direction of heat current, and this is called thermal Hall signal. You see Hall conductivity sigma xy. So similar kind of thing is kxy. This is called thermal Hall conductivity. So this phenomenon has been already observed before, but the reason for this phenomenon were due to ferromagnetic insulators. Like this phenomenon has been observed in kind of ferromagnetic insulators, and due to magnons or in frustrated quantum material due to Majorana fermions. So the reason behind it was phonon was not considered before this paper. So in this paper they have addressed the question like if phonons are also playing role in a more common way than people think. So what they did, they started looking this effect in strontium titanate. This material is strontium titanate is kind of it features kind of structural domains or chiral structure by nature. So it is obvious that these materials can display such effect, and sure enough they have observed kxy signal in these materials. So it was expected, and they observed this signal. Similar behavior is also observed in silicon dioxide, and now again they investigated magnesium oxide. So this is highly symmetric crystal, and it is also non-magnetic. So one should not expect this kxy signal in this material. So, and also they investigated this effect in intrinsic semiconductors like germanium and silicon, and they observed a strong kxy signal for these materials also. So the observation suggests that the thermal Hall signal is more general property of crystalline lattice rather than because of some impurity or some Majorana fermions or any other excitations. They have summarized their observation like for all different materials the Hall conductivity is related to regular thermal conductivity by this formula, and this is kind of pattern suggests that there could be a common underlying mechanism at play across all these very different crystals. So what they try to establish that the observation of thermal Hall signal is not just because of magnons or any other magnetic impurities. It is intrinsic property of crystal lattice phonons.